Hi guys, good morning.
Morning, sir.
Any question, anything we can discuss? Just wait for 1 or 2 more minutes. 1 minute. Oh, let's join. Okay, fine. I think we should start now. Maybe others will be joining. Okay. So, any question on the topic what we have discussed so far? Anything you want me to repeat or any other question in general? No. Okay. My voice is audible. My screen is visible.
Yes.
Yeah, yes.
Okay. Okay. Fine. Perfect. Let's start then. So yesterday we were talking about data cleansing activity, and we have discussed that this is one of the activity which you have to perform before loading data in which layer, staging or integration, which layer?
Staging.
Staging, correct. So before loading data in staging, you should do the data cleansing activity. Okay, and a few of these activities we have discussed are like deduplication and duplicates, missing mandatory column values, missing business related values, such as number of shares, price per share, buyers and transaction, data threshold limit. Data threshold limit is same as variance, which we have discussed yesterday. Okay. Fine, moving to the next one, business intelligence. Okay. It's a branch of data warehousing designed for decision making. Yeah. So what all like things which we are doing so far, like extracting data, loading data in a stage, and then moving, applying transformation logic, moving into the integration layer, and then to access layer. So the purpose of all these things is to generate a report, okay, or to create a report, and based on that report, the business stakeholders, they can understand that how the business is performing, right? That's the main thing, because if anyone has started a business, they are interested to understand that how the business is performing, how much profit they are making, if there is any loss, so how much loss and all those things, so that they can modify the business accordingly. They can make some rules and regulations, policies accordingly, right? So that's what is a business intelligence. So it's a branch of data warehousing designed for decision making. So it's like for decision making. So how you can make decisions, because you'll be having access to reports, and as per that you can take the decisions. Okay. So your OBI report, Power BI, and all those things, this all comes under the business intelligence. It plays a major role by analyzing the data. Yeah, of course. So here you are analyzing the data, you are understanding how the business is performing, where you need to do changes, and presenting it to the business users. Okay. So business intelligence is talks about reports, about the numbers and all those things. And this is generally used by the business users or the stakeholders. Okay. Then we have OLAP. Uh, Oh, I think I've discussed about OLAP earlier as well. Okay, but now OLAP is their online analytical processing. Okay, and this is to process or analyze the historical data to understand the trend of your business. Okay, so whenever OLAP comes to your picture, so the first thing is analysis. Okay, just a minute. So OLAP, when it will come? So the first thing which will come to your mind is historical data. Okay, this will always works on historical data. It means you have started your business on in 2011. Okay, and business was going running perfectly. Then in 2015 you thought that okay, let's create a data warehouse and ETL tool for this project, sorry, for this business, so that everything should be automated. Okay, but then you will think that okay, I have data from 2011 till 2014 and that also should be loaded in data warehouse. So you will load that historical data because now you are in 2015. So for you, the data of 2011 to till 2014 December is like a historical data. So you have to load those data in data warehouse database as well. Okay, so that's a historical data. Okay, and why you want to load it? What's the reason?
To analyze the data historical.
Correct. You can analyze the data and you can understand how the business is performed.
Yeah.
Okay. So see, again, I'm repeating the same thing. The main purpose of any ETL project, okay, the main purpose is to generate a report. Okay, so that you can understand that how your business is performing. That's the main most important task. Apart from this, sometimes we use ETL as well to fetch some data, to get some useful data. Okay, to apply logics and get some data as well, which is used by some other business users. Okay, so OLAP means historical data, first thing. Okay, and then what else? Analysis, or we're trying to find a trend. Okay, so these are the common things, common words, the keywords associated with OLAP system. Analyzing the historical data. Recommendation engine, yeah. Recommendation engine, you know, like your YouTube, your e-commerce sites. So this all works on the recommendation engine. What is this recommendation engine? Like suppose you have purchased a mobile from Flipkart, Amazon, any platform. Okay, so you will see that they will show you suggestions that okay, you have bought this, so some other customer has bought, apart from this they have bought cover as well, mobile cover as well, someone has taken that insurance as well, right? So they are recommending you that apart from this you can go for this products as well. So how it is working? Because they have their algorithm working at the back end. Okay, so which will suggest you that okay, Mr. ABC, if you are buying this, no, so you should buy this product as well along with this, because many customers they who has bought this product, so they are buying this as well. Okay, so how it is working? That is working based on the recommendation engine. Like if you're buying laptop, so they will give you suggestions that okay, you should buy this mouse as well. Okay, that you should buy this drive other thing bag as well, like that. Okay, they will give you the recommendations. So that is working on the recommendation engine. How the recommendation engine is working? They have the trained of data, historical data, and as per that they're doing some analysis, and then they are giving you the suggestions. Okay, you have bought this, so you should go for this as well. Okay, so your OLAP system is you are working on historical data, you are loading it and you are analyzing it to understand the business trend, and that that can help you to make policies accordingly. And a recommendation engine is one of the examples. Any question on OLAP? This is not over. I have few more slides on this, but this is very high level. I've tried to explain here. Any question on this, guys? OLAP? No. Okay. So moving to OLTP. OLTP is online transaction processing. Okay, transaction processing is you are loading your day-to-day data. Okay, day-to-day transactions. Okay, so that system is online transaction processing. Suppose yesterday data, what all transactions happened on yesterday. So I'm going to load those transactions in database. Okay, so that will be your OLTP system, transaction processing. So that will not help to make a trend. That will not help you to make an analysis, because always the trends or the analysis are made on some good amount of data. Then only you can make a trend, right? Then only you can make a trend. If you have just 1 to 2 days data, it is difficult to understand how it is performing, right? So always for analysis, we want some good amount of data, okay, historical data. So OLTP means transactional processing. It means you are loading transactional data, day-to-day data in your data warehouse or database. That's what I mentioned here, day-to-day transactional data of an organization. Okay, day-to-day daily transaction data of your organization. But this will not help you to do some more analysis. Yeah, you can do some analysis, but the analysis what you can do on historical data, that will be far better. Why?
Historical data, more data, but here less data.
Correct. In historical data, you have this large bandwidth of data, and on that you can make
Yeah,
some
yes.
analysis, right? Like
Yes.
suppose if I will ask you that, okay, tell me your fifth semester marks. So from that, I cannot understand. Maybe you would have a scored 80% in fifth semester. Okay, and someone in first semester he has scored 90%, and in fifth semester he has scored 45%, right? So from first semester, it is difficult for me to make an analysis that how is your performance, right? But if someone will give me that, okay, first semester to eighth semester marks, then I can understand that, okay, he is a consistent performer or occasional performer. Sometime it happens that particular student he will score 90% in some semester, and the semester it will come to 70%, 65%, like that, right? So from historical data, I can make an analysis. If you want to see the track of any player, cricket player, so how they will do the analysis, they will see that how many runs he has scored overall in test match, in one day match, T20, and all those things. So from that they can make an analysis that, okay, this particular player is this is the average, like Rahul Dravid. Okay, how means we have that performance of the Rahul Dravid, like he's a consistent performer, right? Correct, no? So he's a consistent performer. But simultaneously, if you see some other like Shahid Afridi or Virender Sehwag, so you cannot trust them. Maybe they can give you some very good strike rate, or maybe they will be out at some other occasions, right? So how you're coming into to this conclusion? Because you have seen their performance for like close 10 years or 20 years of time period, and then you have made this image. Okay, is that clear, guys?
Yeah.
Okay. So similarly in IPL, suppose a new player came and he's scoring very well. Okay, so but from that 1 or 2 match, you cannot make a clear picture that how he will be performing in future, right? So that's what OLAP and OLTP system. The best example is your ATM. Okay, in ATM, like once you are done with the transaction, immediately you will get a receipt, right? Once you have withdrawn the cash, immediately you will get a receipt. So how it is happening? That's based on the OLTP transaction. So what all transactions you have done, so immediately they will save that, and you will get a receipt of the transaction. So that is immediately transactions they are doing. Okay, but that is not for analysis purpose. That is just for the generation, just for the information purpose, right? Similarly, your online booking, okay, your ticket booking and all those things. So the moment you will book a ticket, immediately you will get a response. Maybe if you have tried booking a ticket on Paytm or Make My Trip or Yatra or any other application, no? So the moment you will book a ticket, you will get that ticket itinerary details and all those things, right? That your ticket has been booked. But suppose the same ticket agency, maybe Make My Trip, if you want to understand that most of my customers, where they are traveling from which location to which location, so which data they want, OLAP or OLTP?
Well,
No, they want to make some analysis.
OLAP.
OLAP, right?
OLAP.
yeah.
Because they want to understand that, okay, how many customers has moved from this location to this location, or if you wanted to understand that most of the customers, they are going from which location to which location, how many customers are booking domestic travel, and how many of the customers are booking international travel, right? How many of them are going on both onward and return journey, right? So they want to calculate all those things. So they have to work on some OLAP, right?
OLAP.
They have to gather data of 1 year, 2 year, 5 year, like that, and then only they can make some conclusion. They can draw some conclusion, right? But from 1 to 2 day or 1 week data, they cannot tell that, okay, most of the customers, they are moving to this area or that area, right? Similarly, some that agency, like, have you heard about Modi's rating or some other rating agencies? So they will rate your organization, or they will rate different means institutes and all those things. So how they're rating, or your colleges, they get a rating, okay, from NAAC, NAC, right? They used to give ratings. So how they're giving rating based on the overall performance of the college
OLAP.
throughout the year, right? And that is OLAP. So now I think OLAP and OLTP is clear, guys.
Yeah.
Okay.
Yeah, clear.
Uh, Fine. So this is just a diagram, a schematic diagram I have shown you. Okay, OLTP database, OLAP database. OLTP database means business process. So what all things are happening on a daily basis in the business, that will be stored in OLTP database. You can see I mentioned here data transactions. Day-to-day transactions will be stored here, but you cannot make some conclusion. You cannot draw some conclusion based on this, right? And OLAP database, business data warehousing. Wherever OLAP will come, that is data warehouse, and OLTP means database. So that's also one of the differences. OLTP that is used for database, and OLAP corresponds to data warehouse. Okay, like in warehouses, they used to, means if you go in Amazon warehouse, a Big Bazaar warehouse, a Groupal warehouse, so they have that warehouse, and we have bulk of data there, bulk of items and there, right? That's why the name came data warehousing, because we have bulk of data stored in OLAP database. Data mining, data analysis, big data. This is the example of OLAP, and that's what I have mentioned. This is used for data analysis, and big data is the perfect example, right? Big data. This term came because of the huge volume of data. Okay. Any question, guys, on this? Okay, so now these are the differences. So I have shown good amount of differences here, but all these things maybe if they will ask in the question interview, so you can tell 2 to 3 differences or 4 differences, that is more than enough. Okay, so let's have a look over the differences between OLAP and OLTP systems. The same thing will come, whatever we have discussed, the same thing will come. Consists of historical data, right? We have seen OLAP consists of historical data from various databases. Sometimes we have multiple databases, and from all the databases we will get data. We will load data in one data warehouse. Okay, so that consists of historical data. But OLTP consists of only operational current data. Correct? No, this works only on operational or current data or transactional data, right? It is subject oriented, used for data mining, analytics, decision making, etc. Okay, we have discussed this, that OLTP is used for decision making, for analysis purpose, and all these things. Subject oriented means you have a particular agenda for this, that okay, I want this data and I want to do this analysis, right? It is application oriented, used for business tasks. It's used for day-to-day task, that okay, how many customers visited my store yesterday, particular snacks, how much it was sold, which and then the total profit we have made yesterday, total cost we have made yesterday, and all these things. So this is just for day-to-day transactions you can store. But of course, when this will mature, when your OLTP system will mature, then you can pull this data in your data warehouse and you can use this for analysis purpose. Okay, so it is like this. So the data of your database are finally moved to data warehouse. Okay, for analysis purpose. Any question, guys? Is it clear? Hello, any question?
Yeah, clear.
Clear? Okay, fine. So OLAP data used in planning, problem solving, and decision making. Again, the same thing is coming. This is for planning and problem solving and decision making. Okay. Data is used to perform day-to-day fundamental operations. Same concept. It reveals a snapshot of present business tasks. It provides multi-dimensional view of different business tasks. Yeah. So here there is one limitation. Okay. This can give you a snapshot of present business task. Okay. Present business task means here you will get data of particular source generally. Okay, so a snapshot of present business task, what was happening, so you'll get that information. But in OLTP you are not bothered, you're not bothered about analysis, you don't have any agenda. So what you will do, you will dump data of all the sources or all the transactions, whether it is profit, whether it is cost, whether it is taxes, whether it is assets, liabilities, revenues, whatever it may be. So we are dumping all the data in OLTP because we don't have any agenda. The only agenda is that what all transactions are happening on a daily basis. I want to dump data. So that is what OLTP. But in OLAP, suppose you want only taxes data, how much tax I have paid to government for the last 5 years. So what you will do? You will store only tax data in OLAP system, right? You will not store revenues data or assets data or profit data or loss data, right? That's why you have an agenda here. Large amount of data is stored typically in terabytes and petabytes. Yeah, in OLAP you will be having large amount of data. Then only you can do some good analysis, right? The size of data is relatively as small as the historical data is archived, for example, megabytes and gigabytes. Yeah. So in OLTP system, you don't have that much huge amount of data. Okay. But you can ask a question here that, okay, then you are telling that in databases, we are storing day-to-day data. Okay. And suppose this database we have started in 2019 and now we are standing in 2021, right? So we have close to 3 years of data into this, 2019, 20, and 21. So can I call this database as a data warehouse? What do you think? Can we call this database as a data warehouse? Hello. See, now you are standing on 2020, 2021, so it's almost 3 years. So now you have 3 years of data in database. So generally, what happens now? So after a certain period of time, and that depends on the project, business to business, what they will do, they will archive this data or they will move this data to data warehouse. Maybe if some business is having their operations for the 6 months, so what they will do, they will store only 6 month data here. After that, once the 6 month is over, they will take this data, they will move that to data warehouse. So that's why in databases, you will not store your full historical data. You will keep that 3 months data or 6 month data or like that only. Okay. I think this is clear. Any question on this slide, guys? Anyone? No questions. Okay. Relatively slow as the amount of data involved is large. Queries may take hours. So why I'm telling that this is a relatively slow data warehouse?
It consists of more data. We will give queries joins.
Yeah,
We
correct.
have to apply more joins.
Correct. So this consists of large amount of data. Okay, and obviously when you have large amount of data and if you're writing, even if you're writing a single query, so that query will scan all the data. Okay, terabytes of data. So that will take time. So that's why data warehouses are relatively slow. It takes time. Okay, and this is very fast as the queries operates on 5% of the data. What it means? Who will tell me what it means, guys?
Because it consists of less amount of data, it will take less time to query.
Correct. The data is less here as compared to data warehouse. Okay, because they have only day-to-day transaction data. So that's why it will be faster. Okay. It only need backup from time to time as compared to OLTP. Why I'm telling that data warehouse needs backup from time to time as compared to OLTP? See, here what is happening? Right now, I have told you that in databases, okay, you have 3 years of data now. So what you will do, you will take a backup in data warehouse, right? Because you don't want to make this very bulky. So that's why you want to move this data in data warehouse because you have a strategy that, okay, I want only 6 months data. Okay. Suppose your database, you started your database in 2020, 2021 Jan. Okay. Jan. Now you are standing in 2021 July. So now how many months of data you have? January, February, March, April, May, June. 6 months data you have already. Now you are standing on 2021 July. So what you will think? Come on, guys. What you will think here? You will think that I already have 6 months data, okay, in my database. Now let's move that 6 months data where?
Warehouse.
Data warehouse. Yeah. So you remove that 6 months data in data warehouse. Okay, so that's what you have to take a backup of database always in data warehouse. So I have just taken an example of 6 months here. Okay, randomly I've taken a duration. So, but that totally depends. Okay, and the concept is like you have to take a backup of database in data warehouse. Okay, so you will get two benefit here. Your data warehouse will get again new set of data, and now the analysis will be far better. Now, please make a note of a point. Okay, thumb rule. Whenever you want to make good analysis, so try to take more and more data. So the more data you have, the analysis will be far better. Okay, and again the same example, the marks example, what I have told you. Okay, so always analysis are better on a huge volume of data. Okay, or big set of data. So that's why databases data will always be taken backup in data warehouse. This data is generally managed by CEO, MD, and GM. Yeah, of course. So, CEO, MD, and GM, okay, they will not call you on a daily basis and they will ask you that, okay, what was the transaction yesterday? What is the transaction tomorrow? They want to see a holistic picture. Okay, that for the last 3 months, how much business was performing, last 6 months, how it is performing. Like the companies, they used to publish quarterly their their annual quarter results. Okay, and in that they will mention, okay, the company has performed in this area. This was the total profit we have made and all those things. They are not telling on a daily basis, no, that okay, today we have made this much profit, yesterday we have made this much profit. No, they are giving quarterly results or half yearly results or annual results. So that's why data warehouses are used by CEO, MD, and GM because they want to see the holistic picture that for a particular duration of time, how my businesses perform or it is performing. This data is managed by clerks and managers. Yeah, why? Because this is the day-to-day basis. They will manage it. Only read and rarely write operation. Both read and write operation. What is the meaning of this? Read and write operation.
Rarely we used to insert data in this.
Okay. See, in historical data, it is like you are taking a bulk of data and you're moving it there, right? Correct, no? You will move it there. But in database, what is happening on a daily basis? You are inserting records. That's what example we are seeing for the last 1 week that we have source file and we're loading data in a staging area. So what is that happening? On a daily basis, you're getting source file data and you're loading that data on a daily basis in your staging table. So that is happening continuously, right? You are inserting record. And like we have discussed the scenario where the source team has sent you data, but that data was not correct. That was incorrect. So we have seen that he will send you data again. So that's like an update operation will happen. So in database, what will happen? Your insertion of data, updation of data will be very frequent, right? So that's what read and write operations will be very frequent in database. But in data warehouse, it is not that much frequent because we're just moving the bulk data from one place to another place. Okay, is this clear, guys? Any questions so far about OLTP and OLAP system? This is important here from your interview perspective, especially for freshers, they will ask these questions.
Sir, yeah, in
Hmm.
database, backup and recovery process is maintained religiously.
Which one? That's
Is
what I told you, no?
second.
That's what I told you. Religiously means that is you have to be very much cautious about this. You have to do this punctually. Like here, suppose I have mentioned that okay, 6 months. So after
Yeah.
6 months, you should move the data from database to data warehouse. That's what you should be. You should be very punctual in moving data from database to data warehouse. Why? There are two reasons. You don't want to make this bulky database. Okay, and that when you move this data to data warehouse, so now in data warehouse you have a large set of data. Okay, and then your analysis will be far better. So the taking backup of database in data warehouse should be very punctual. You should be very following it very religiously. Okay, that's what I mentioned there. Is that clear?
Yeah, clear, sir.
Okay, any question in general? Yeah, Swati was asking something.
No.
Okay, perfect. Okay, so I think we have discussed a good number of points about OLTP and OLAP. Okay, now let's move to the next one. So data warehouse, if they see these three terms, no, these three terms are related. Whenever data warehouse will come into picture, I mean historical data. Whenever historical data will come into picture, it means we are working in OLAP system. Whenever OLAP system will come into picture, it means data warehouse. Whenever data warehouse will come into picture means historical data. Okay, so these three are correlated. Don't get confused. Okay, fine. Okay, database means transactional data or real-time data or operational data or day-to-day data, whatever you want, you can write. And then it means OLTP. And this is ACID, atomicity, consistency, isolation, durability, compliance. Actually, this ACID is a property of loading data, storing data in database or data warehouse. Okay, this is a big term. It will take time for me to make you understand. But this is the this is some like protocol which you have to follow whenever you're designing a database or data warehouse. Okay, database generally, not data warehouse, because data warehouse you're not planning a transformation logic, you're just dumping the data. Okay, it's like a blind person just dumping the data. Okay, so database, transactional, OLTP, right? Data warehouse, historical, OLAP. Okay, now is this clear? We have three keywords: data warehouse, historical, OLAP, database, transactional, OLTP. Okay, now tell me, my day-to-day activity data, where I will store, in database or data warehouse?
Database.
Database.
Database. Okay, that's an OLTP or OLAP?
OLTP.
OLTP.
OLTP. Yeah, perfect. Okay, now tell me, YouTube. Okay, they want to understand that how many videos were posted on my platform were related to political views. Okay, political videos. So they will take OLTP system or OLAP system.
OLAP.
OLTP.
OLAP system. Very good. Okay. Facebook wants to understand that how many posts were posted on its platform on 29th March 2021. So which database?
OLTP. OLTP.
OLAP.
No, he just want on 29th March
Day.
2021 on a
OLTP.
particular day only.
OLTP.
Correct?
OLTP.
OLTP. But if I will ask you that, okay, Facebook, Mark Zuckerberg, he wanted to understand that how many total videos posted till now, okay, of related to political views. So he will go for OLAP. Okay, but if I'm talking particular day, so he will go for OLTP.
OL.
Correct? Okay. Now suppose big billion days. Okay, you have heard about the Flipkart big billion days. You all know that, right? So suppose the Flipkart CEO, he wants to understand that, okay, how much total profit we have made in big billion days. Okay, so now tell me, OLTP or OLAP system?
OLAP.
OLAP. Anyone else?
OLTP.
OLAP. Okay. Okay. Oil or big billion days, it went for how many days?
Less number of days.
4 to 5 days.
4 to 5 days, right? So 4 to 5 days, you cannot consider that for analysis, right? Whenever you're going for analysis, that will be minimum 6 month, 12 month, or more than that. Okay. So he is not making any analysis. He just want the number of means he just want the number that what's the total profit we have made during big billion days, right? If he will tell that, okay, tell me for the last 5 years that the profit made in each and every year during the big billion days, like in 2016 big billion days, how much profit we have made? 2017 big billion days, how much profit we have made? 2018 during big billion days, how much profit we have made? Then it will come under which category?
OLAP.
OLAP.
OLAP, very good, because he wants to understand that how was the trend, right? So that's why he wants to understand for the last 5 years. But if he will ask you that, okay, from 2020 to 2021, tell me total profit we have made during big billion days.
OLTP. Only 1 year.
OLTP, only 1 year, and he don't want to do any analysis. He don't want to do comparison, right? That is OLTP. So now I think this is clear, no? OLTP and OLAP. Okay. Now database and data coming to database and data warehouse. Okay, this is again same thing will come. Database is designed to record. We are loading the record system or daily basis. Data warehouse is for analysis. Okay. Processing method is OLTP here, OLAP here. I'm moving a little bit fast because all these things we have covered. Usage. This is used for perform fundamental operations of your business. Means day-to-day operations, what is happening. Database is used for that. But data warehouse allows you to analyze your business. Tables and joins. Tables and joins of a database are complex as they are normalized. Tables and joins is simple data warehouse because they're denormalized. Okay, this point I will tell you. Okay. Normalization is a technique like first normalization, second normalization, third normalization, all those things. And this is a very common and useful and important concept of designing in a database. Okay. So this is something like how you have to design a database. This will tell you about that. So whenever you're designing a database, you should follow this normalization. Generally, we used to follow third normalization. Okay, I don't want to go into that normalization concept and all those things because we will deviate from this topic. But if you're interested, you can let me know. I will discuss that later point of time. Okay. So when you are designing database, you have to be very cautious about normalization techniques you're following or not. But in data warehouse, there are no concepts of normalization. There are no rules and regulations. Why?
Dump the data.
Because we are directly dumping the data, right?
Yeah.
We'll take that data, okay, in a container and just we will dump it like garbage. Okay, you're throwing garbage. So you're not bothered what is there in that. You're just taking that dustbin and throwing it, right? So that's why it's like a data warehouse is like just dumping. You're not bothered about that. But database, you went to a mall, you have done some shopping, now you came to your house, right? So you will do a segregation of the items of what you have bought, right? So the clothes you will keep that in your means wardrobe, and kitchen items will keep it in kitchen, okay, and those items which are dining space will keep that in dining space, like that we'll do segregation. So you have to follow rules and regulations, and that will be complex and it will take time, right? But throwing dustbin, throwing garbages, that's not something complicated. You don't have to do any calculations. Is that clear? So that's why in database you have, this is complex because you have to follow rules and regulations. For data warehouse, no rules and regulations, just dumping the data. Orientation is application oriented collection of data. Okay, it's subject oriented collection of data. It's application oriented. Why I mentioned application oriented means because here for a particular application we are loading all the data, but this is subject oriented. We have an agenda here that I want the total data of revenues or assets or whatever it may be. A storage limit, I think we have discussed, this is limited. There's no limitation. You can have from n number of applications, and this is very huge. Availability, data is available real time. Why I mentioned real time? Because day-to-day transactions are happening here, and here data is refreshed from source system. Refresh means you're taking copy, you're taking what I can say, sorry, I forgot the term what I mentioned at that time. Backup, right? You're taking a backup from the source system or from the database from time to time. That's what you're refreshing the data from source system, and then you are loading that in data warehouse. Now I have a question here. Do we have same job for database and data warehouse? No, guys, come on, tell me. To load the data, the job will be same for database or data warehouse, or is different?
No, different.
Different, right? Because the logics are different. That's when the jobs will be different. Okay, is this clear? No,
Yes.
tell me. Okay,
Clear.
perfect. Now tell me, the job to load data in data warehouse, will you will run that on a daily basis or monthly basis or quarterly basis, like that?
Depends.
Quarterly basis. Means,
Quarterly basis or 6 month basis, right? Or semi-annually basis or annual
yeah.
basis, right? But
If it is
database
daily
job,
basis, it is database.
perfect, very good. Why you will run the database job on a daily basis?
Database is nothing but OLTP, day-to-day transactions. Data
Day-to-day
warehouse.
transactions.
Uh,
Perfect, because the day-to-day transaction, that's what you want. Daily data. Okay, very good. Usage ER modeling techniques. Yeah, ER modeling techniques. Anyone who knows here ER modeling techniques? What is ER modeling techniques?
No, sir,
Entity
but
relationship.
Perfect,
in
very good.
interviews they are asking dimensional data modeling and entity relationship data modeling.
Entity relationship modeling techniques. Okay, I will do one thing, yeah, because I will take one separate session. Okay, and I will tell you some basic concepts of data warehouse database as well. You see, actually, what the thing is, like your ETL, your database, your data warehouse concepts, okay, your SQL concept, these all overlaps. Okay, there's no strict segregation, right? So whenever I'm teaching you this now, so some of the terms of database will also come into picture. So I will do one thing. I will tell you, I will take a very simple example. And I think in 10 to 15 minutes, I will cover that and I will tell you what is ER diagram. Okay. But to a very high level, ER modeling techniques, ER stands for entity relationship technique. Okay. So whenever anyone is designing a database, suppose maybe you have, I have studied in a college, right? I've done my BTech. So that college management will approach me and they will tell me that, okay, can we design a database for our system? Okay, design database for our system. So I will ask the question that, okay, what all information you want? He will tell me that, okay, design a database so that I can get information about all the branches what we have. Okay, first thing. Then HODs of each and every branch. Okay. Then information about each and every semester. How many subjects are there in each semester? Who are the facilitators in each and every semester? Then coming to the about the students. How many students are there in each and every branch? Similarly, in each every semester. And what are their backgrounds? Okay, their gender, their date of birth, okay, their native place, how much marks they have scored, who is the topper, and all these informations. So now here we have multiple entity. The first entity is about branch. So I will create a table in which you will having branch information. So that particular will be known as that particular will be one entity. Then information about HODs, that will be separate entity, right? And then information about facilitator or your teacher, that will be separate entity. Information about a student, that will be separate entity. Okay, so very high level. Now you can say you have 4 to 5 different entities, right? But you have to find a relation among them. It's not like that you will create this table separately. There must be some relation between these two tables because you're creating a college database and all the informations are related, right? If you have a branch, you will be having HODs, right? Now, if you have HODs, there will be some facilitator working on those HODs. If you have facilitator, there must be a student to whom you will be teaching. If there are students, they must be in different semesters. They must be studying different subjects. If they're studying, they must have scored some marks. If they have scored marks, they must be topper, right? So they all are related. So you have to find the relation. So that's why the name is entity relationship modeling techniques. I hope little bit it should be clear, right? You got an idea. So here, if you're designing database, you have to be very much cautious about the modeling techniques, and generally ER modeling techniques is used. But in data warehouse, we use data modeling techniques. Data modeling techniques is very straightforward. No strict protocols you have to follow. Just you have to design a table, okay, where you can just dump the data. No need to follow any normalization. No need to follow acid property and nothing else because they're just dumping the data. The best example I told you about that garbage what you're throwing. You're not bothered about that what garbage you're throwing, right? And all those things. Is that fine, guys? Database, data warehouse. It's clear. Any question do you have?
No.
Clear.
No, these are the few of the more. I have taken a lot of points here, so don't get confused or don't be in don't get afraid that okay, all these points are there. I have to remember all these points. So don't remember it. If you understand it, no. So all these points they are more or less same. Okay. The storage limit generally limited to single application. Database is limited to single application. Here you have number of applications. Availability. This is on real time data. This is like data is refreshed from source system. ER modeling techniques, I think same thing is coming. Data modeling techniques, capture data, analyze data. Here we are just bought about capturing the data. Native data, just we are capturing it. But here we are analyzing the data, same concept. Data stored in the database is up to date. Yeah, this will be up to date. That's a very important point. But in here, data warehouse, it will not be up to date. Why I'm telling that data warehouse data will not be up to date? Why?
It is historical data, means large.
Historical data is there, right? Suppose this,
Yeah.
take this example. Okay. Now we are standing suppose on 2021 December. So database you will have data of 2021 December as well. But if I will ask you that in data warehouse, so you have data of which period? So maybe data warehouse, you'll be having data of 2021 July only, because you have a tendency, you have a policy of taking backup after every 6 months. In data warehouse, you have data of 2021 July only. So when you will load data from August till December, so once you move to 2022 January, then only you will think that okay, now we should move the data from August to December in data warehouse. That's the data in data warehouse is not up to date, but databases are also always up to date. Flat relational approach methods use data warehouse use dimensional, same thing. Yeah, same thing is coming. Star snowflake schema, I will tell you in the coming slides. Simple transaction queries are used, complex queries are used for analysis purpose. This depends actually. Okay, why I'm telling simple transaction queries are used here, because if you want to fetch information, like I want to know that total profit I made yesterday, total cost yesterday, so queries will be simple. But here sometimes data warehouse you have to make complex queries because you want to see the trend, you want to see the increase or decrease in percentage and all those things. So queries can be complex here. Now tell me, data scientist, they'll work on OLTP system or OLAP system?
OLAP.
Very good,
They
perfect.
want to analyze the data.
They want to do the analysis of the data. Perfect, very good. Retail data is stored in database. It stores highly summarized data. Yeah, in data warehouse we have summarized data, but in database we have detailed data of daily transactions. So what all transactions are happening, we will store each and every data in database.
Sir, here
Mhm,
data
yeah.
warehouse uses dimensional and normalized approach for the data structure. In the previously data warehouse means denormalized, you say.
Data
Here it is
warehouse
denormalized.
denormalized. Yeah, where I mentioned?
But here it got normalized.
Which point can you tell me?
Storage of data.
Warehouse use dimension and normalize approach to data structure. Example, storage snowflakes. No, I think this is a good point. This is not like that. They're not using that normalized approach for data structure. Normalized star snowflake. No, leave it. I mean, I will come to the star snowflake schema. I will tell you. But I think this is confusing point. So data warehouse, it doesn't go for normalized approach. No, this is incorrect. Okay. Database go for normalized approach. Good catch. Okay. Perfect. Next one, applications of database. Okay, your banking sector, it works on database because day-to-day transactions they have to store. Your airlines, your universities, telecommunication, finance, sales and production, manufacturing, something. So guys, just you can go through this, and I think now you can correlate that why I'm telling that this sectors they works on database because they are having a lot of transactions happening on a daily basis. Your telecommunication, you can understand a lot of calls, incoming and outgoing calls are happening. The telecommunication, maybe Airtel or Geo, they have to maintain a database so from which they can get the information that okay, how many daily transactions are happening, right? Okay, do you want me to explain this slide? I think this is very simple. You can go through this and you can understand your HR management, right? They want to see the total daily basis that what are things are happening with the employees, the salary structure, the increment, decrement, and all those things. Okay. Applications of data warehousing. Applications of data warehousing. Your airline is managed relevant descriptively in the healthcare sector. Patient statement products, insurance sector, retention, innovation. Yeah, actually, this is from analysis purpose. Okay, you might be thinking that banking, I have mentioned database and data warehouse as well. So banking in database means day-to-day transactions we are storing here. Okay, but here it is like you have to do the analysis on that. Okay, this is for the analysis purpose. If you're getting confused with this, don't get confused. So the concepts what I have told you, keep those concepts in your mind. So whenever you want the trade transactions, you have to work for OLTP. When you want us to do the analysis, you have to go for OLAP or data warehouse. Okay, now coming to a star schema and a snowflake schema. Before this, any question, guys? No questions? Okay, I'm not sure why we have less attendance today. Is there any holiday or any festival today?
No.
Oh, okay, fine. Because the star schema, snowflake schema is a very important concept, and I want everyone to attend. Okay, fine. So now, anyone, do you guys have any prior idea about the star schema? What is this? No.
Like we have dimension tables and the fact tables and star schema.
Okay, correct. Very good, very good. I'll come to that. A star schema, data warehouse, fact and dimension tables, few foreign key joins. Okay, I will come to this. Why I mentioned a star schema to data warehouse? Why I mentioned fact and dimension tables? Why few foreign key joins? This is very specific to table structure of your RDBMS system, relational database management system. Okay, they'll try to make you understand that what is this all about. Okay, I have an example here. Now leave this slide. I think this slide is useful and this slide is useful. This one, this slide is useful. Okay, now before going to a star and snowflake schema, just let me show you two slides. From this, it will be easy to understand. Okay, suppose this is a fact table. I'll leave this dimension tables and all these things. So, and what is dimension table? What is fact table? We'll see that as well. Okay. So first of all, so suppose concentrate on this table, which name is revenue. So you have dealer ID, model ID, branch ID, date ID, units sold, and revenue. So this table is giving you information about dealer ID, model ID, and all those things, and units sold and revenue. Okay, how many units they are sold, and what is the total revenue. And then for the dealer ID, you have this dealer table. So this dealer table will having a dealer ID. From this dealer ID, you have location ID, country ID. You can see the dealer name and dealer contact. Okay. Now here, then you have branch ID. So branch ID, more information you can get in this branch dimensional table, right? Because here it is just showing you branch ID. But if you want to see branch name, you have to go to this table, right? If you want to see the branch address, this table will give information. Branch country, you will get the information from this table. Okay. Similarly, if you want to see the information about product, okay, you can see product name and all, model ID, variant ID, everything is present here. So now, try to understand this. Is a very important and core concept of data warehouse or database, anything. So did you understand the structure of this, what I'm trying to tell? You have a main table, which is known as fact table. This fact table is not giving you any information. This is just giving you the numbers, dealer ID, model ID, branch ID, date ID, units sold, and revenue. Suppose if I will not show you this 4-dimensional table, the dealer table, date dimensional table, product table, and branch dimensional table, I will show you this only revenue table. Now tell me, from this table, can you tell me the dealer ID name? This table will give you the dealer name.
No.
No, correct. And from this table, can you tell me who is the branch name? What's the branch name?
No.
Branch address?
No.
No. Okay. From this table, can you tell me when that particular product was sold, on which date, month, and quarter?
No.
No.
No. From this table, can you tell me that what's the product name?
No. Only
No.
IDs.
No, right? Okay.
Yeah.
Then now the question is, this table is not giving me the sufficient information. I do understand this is giving me the IDs, right? But IDs and units sold and revenue. But I want to get the more information about that ID. It is difficult. Suppose the principal called me. Okay, I designed the database of that particular college. He called me and he told me that, okay, who is the topper in electronics and communication branch? I will tell him that, okay, roll ID 456 is the topper, and he has scored total marks 450. Is that information sufficient for principal? Or he will ask some more information from me. Hello. If I'm
Yeah.
telling that roll number 456 is the topper in electronics and communication branch and he has scored 450 marks, is that information sufficient?
No.
No,
Oh.
because you want to tell name.
Yeah, very good. Because maybe he will ask, okay, then we tell me his name as well. Okay, his name is Mr. Maybe anything, Mr. Raj. Okay. Okay, then maybe he might be asking, okay, tell me he's from which place? Okay. What is date of birth? What is the gender? Share his contact number. I want to congratulate him. Maybe he can ask all these informations, no? Right? So that's why now the question is, you can ask me the question that then why I am maintaining this table? Why I'm not kept all these informations, name, address, country, dealer name, dealer contact, month, quarter, date, and product name and all these things in the one table only. Why I have flooded separate tables? What's the need of this? Are you getting your point?
Yeah.
Let me design database of ABC College of Engineering. Okay, this is the ABC College of Engineering and we are designing the database. Try to understand this. Okay, first of all, I have designed a branch. First column is branch. Okay, and maybe we have AC branch, CS branch, mechanical branch, civil branch. What else? Electronics, computer science, mechanical, civil. You have biotechnology. What else you have? Come on, guys. Sorry, I forgot. Mechanical. Chemical. Right? Chemical engineering is also there. So you have these
IT.
branches. IT. Yeah, I think CS will come inside that. Okay, IT, information technology and information science. Yeah, we have those branches. Okay. Now HOD ID. Okay, HOD ID 1, 2, 3, 4, 5, 6, 7. Okay. Then someone told me that okay, HOD ID, it is difficult to find the name. Give HOD name as well. Okay, then I gave the HOD name as maybe Rajkumar. Rajkumar is the HOD here. Okay, and maybe Shruti is the HOD of CS branch. Raman is the HOD of this branch. Abdul is the HOD of this branch. Hema is the HOD of this branch. Karan is of this branch, and Lata is of this branch. Okay, they are the HOD name. What else information you want? Is this sufficient?
Address.
Sorry,
Contact address.
sorry, I'm not getting a point. Sorry, can you repeat?
Contact.
Contact number, very good. HOD contact number. Contact number of HOD. Okay. Take the number, random number. This is the contact number of this person. This is the contact number. What else? What else, guys? Go on.
Address.
Address also you want, okay? Address maybe Delhi, Kolkata, Chennai, Hyderabad, Bangalore, Kerala, Mumbai. Okay, what else?
Pin code.
Oh, come on. Address is sufficient. We can add pin code as well, but just keep till here only. What else you want? Semester? Correct?
Yeah.
Correct, no? You want semester as well? Okay, then I have to add semester as well here. Sorry, I forgot the shortcut of that, inserting rows. What is the shortcut? Forgot that. 8 semesters now. Okay, let me make here semester. The first semester. Eight semester. Okay. Now, in all these 8 semesters, okay, you will having multiple subjects. Correct, guys? Hello.
Yes.
Yes.
Just I'm trying to give you a flavor. Insert semester. Generally, how many subjects are there in one semester? 5 subjects?
5 or 6.
5 or 6. Suppose subject is A, B, C, D, E. Okay. Similarly, you will be having for second semester as well, multiple subjects. Okay. Who is the teacher? Teacher name, first semester. Okay. Suppose teacher name is Rahul, Sita, Geeta, and Raman. Okay, one more left is Suresh. They are the teacher names. Okay. Now maybe you want this teacher IDs as well. 1, 2, 3. Taken HOD ID here. 1, 2, 3, 4. I've taken only HOD ID. Suppose just mock data. Okay. Maybe like 101, 201, 301, 401, 501, like that. Okay. And then maybe you want teacher contact number as well. Teacher contact number. We're having some value here. Some value here. Okay. Now maybe then after this you will be having maybe 40-50 students in each semester. Then again in this semester I have to make multiple records for all the students. Correct? 50 records. So now you can understand how much this will be means this will be like a very hectic data, and this will grow like anything, right? You guys are understanding this? Hello. So again, I have to make multiple records for this for each semester, 60 records, second semester, again 60 records, third semester, again 60 records. So this will be very, very huge database or table. Correct? You guys understood this?
Yes.
Okay. So this will grow like anything. Are you getting any idea how much it will grow? Because if I will start getting all those records, it will take good amount of time. Okay, just I
Yeah,
wanted to give you a flavor. Then I have to add the student's name. Okay, then I'll make a column, the student. Okay, the student ID. Then the
student
student
contact number.
gender, student contact number, then location, then marks scored. Correct? This will be very hectic. Then I thought that why to go like this? Do one thing, create a one table branch. Branch is a one table. Okay. And this I'll be having branch ID and branch name. Branch ID 1, 2, 3, 4, 5. EC, CS, sorry, CS, mechanical, civil, IT. This is one table. Okay. Now separate, create a separate table, HOD. HOD ID, HOD name. No, sorry. HOD name. HOD ID suppose it is 1. HOD name, whatever I've taken here. This is HOD names, no? Let's copy it. HOD name. And maybe I can take their location, address, contact. I can give the location, whatever it may be, address and contact. Okay. Sorry. And then I can take semester. I get the code. I can take those details and then I'll make a student table
Student.
and I can get those details. Now tell me which one is more easier to understand, this one or this one?
This one.
Second
Latest.
one, right?
Yeah.
Yeah.
Second
So
one.
what we have done here is we have segregated data. Okay. So now we have, now this will take less space as well because there is no repetition. You see, if I mention HOD ID 1, so same HOD ID will mention here as well, HOD ID 1 here as well, and so all these things will come. Rajkumar name will come for all these semesters and all these things. But here I have this information only in one table. Okay, so that's why this is the reason that you have to create different dimensional table, so to avoid the duplicate records or to avoid the redundancy. You got it? You got any idea, guys, about this? High level, you understood what's the reason?
Yeah, yeah. Yes,
Okay.
understood.
So that's why we don't used to keep all these informations in a single table. Okay, because that will become very huge and that will take good amount of space as well. And this is known as something like normalization. We are storing data in different tables. Okay, so that's the reason. Now, if I want to see dealer details, I will join with the dealer table and I can get all the information, dealer name, dealer contact. Correct? No. If I have to get the branch name, I can join with this branch table and I can get the branch name, address, country. Similarly, if I want to see the date dimensions, I can join with the date dimension table and I can get all the information. Similarly, I can join with product. Okay, so here you have to do the joinings, but you can get all the informations and you can save your disk space as well. So this is the reason we have to create multiple tables. Okay, and this is known as fact table and this is known as dimensional table. Okay, so I will do one thing. So let's just stop here because this conversation will take good amount of time because then I have to compare this with Snowflake schema. Okay, and this is very important from interview perspective, or maybe you are working on live projects, you should have these informations. Okay, fine guys. So any questions so far what we have discussed? OLTP, OLAP, data warehouse, database, applications, usage, the differences. Any questions on this?
Yeah.
No question.
No question.
Okay, perfect. So if there's no question, fine. So I'll stop here. Let's connect tomorrow at the same time. Thank you for attending. Take care. Bye.
Thank you. Bye.
Thank you.